Today we are starting our Unit 3 with first lesson, Lesson 1. And basically this whole unit is on solving quadratics. And today the first lesson is to solve quadratics by isolating the variable. This method is the simplest method that is used on the simpler type of problems in quadratics. Okay, so it only works on certain problems, as you guys will see as we go along. But this is the introduction, really. So we're starting out with the simpler problems. So example 1, a quadratic equation is like this, right? So quadratic is any equation that has x with the exponent of 2 as the highest exponent, right? Highest order. X squared is your biggest exponent on your x, so that's a quadratic. So here's an example. X squared is equal to 9. So basically, what is this asking for? What is x, right? It's asking for us to find x. X is the number that when you square it, you get 9. So you got to be thinking now. It's basically what number times itself, right? That same number multiplied to itself gives you 9, right? So what number do you think that could be, right? So it's actually going to be 3 times 3 equals 9, and negative 3 times 3 equals 9. A lot of times you guys are like, oh, it's 3, but it's not just 3, but it's 3 and negative 3, because negative 3 times negative 3 is also 9. So the way we show the work is that, so basically the process that we just thought about is called square rooting, right? The opposite of square. When you're trying to think of two numbers that multiplies itself to get a number, we're doing what is called the square root. So what I do is you write the square root on both sides. So the square root of x squared is just x, right? And the square root of 9, as we've seen, is positive 3 and negative 3. So that's why we have the positive and the negative sign in front of 3, showing that there are two numbers here, a positive 3 and a negative 3. Okay, moving on to the second example. I have x squared is equal to 8. Again, you've been thinking, what number multiplies itself equals to 8? And that is going to be a little bit harder, right? Because there really isn't a number. 2 times 2 is 4. 3 times 3 is 9. How do you get 8? So it's somewhere between 2 and 3, right? 2 point something. And we don't really want to deal with decimals because it's never exact. So what we do, again, we're going to square root both sides. And then so I'm going to have x is equal to the square root of 8, right? But then the 8, to find the square root of 8, what we do is called prime factorizing first. So I'm going to break 8 down. What is 8 made out of? 2 times 4, right? And because 2 is a prime, I'm just going to circle that. And then 4 is not a prime. I'm going to break it down some more. So it's 4 is actually 2 times 2. And then those are all done. So once I'm done with a number, I can circle that. And those are the numbers I take. Okay, so now I have that. I can go on with my equation. Now I have x is equal to, remember, you do a square root, you get positive and negative, right? And then it's these three numbers that make up 8, right? 2 times 2 times 2. So I leave them in here. And this step here is now called, we're simplifying the radical, right? Radical is square root, is another word for square root. Okay, so here I have 2 times 2 times 2. I replace 8 with 2 times 2 times 2. And what I do is I take a pair of numbers, because square root asks you for a pair of the same numbers. So if I have the same numbers twice, I take it out. So here I have 2 times 2. I'm going to take that out. So those 2 goes outside and have a 2 outside. So now I have 2 outside, and the 2 back here stay inside. Okay, one more time. If you have a pair of numbers, like 2 of them, you can take it outside, and that becomes one of them outside. Just like how you have square root of 9 is 3 times 3, so you just have 3. Okay, so example number 3. Here it's a little bit different, right? Now here you can't square root both sides just yet, because you can't square root the whole thing. You have to get rid of the 2 first, just so you have the x squared by itself. You need to have something squared by itself to square root. You can't have extra things around it. So I have to add 2 to both sides. So I have x squared is equal to 12. And then I square root both sides. Again, the 12, I need to break it down. 12 is 2 times 6. 2 is a prime. Done. 6 is 2 times 3. And I take those. So x is positive and negative of radical 2 times 2 times 3. Here I have another pair of numbers that I can take out. So now I take those two 2's out. I have a 2 outside. right? So now I have x is equal to plus or minus 2 radical 3. The 3 is by itself, it can't come out. Okay. Example number 4. Again, they're adding more stuff. All I got to do is get the thing that is squared by itself. So I need to get the squared thing by itself here. So I got to add 1 to both sides. I get 30. And then I divide it by 2. I get 15. And I square root both sides like that. Okay. Now I break 15 down. 15 is 3 times 5. And they're both primes. So I just take both. So x is positive and negative 3 times 5 inside the radical. Now here, the difference is there are no twins, right? You don't have a pair of the same numbers, so you can't take anything out. So you just leave them inside, you multiply them back. It's just positive and negative square root of 15. Example number 5. Here I have a thing squared equals to a thing, right? So do I square root now, or do I add 3 first? Okay, the answer is you have to square root because this is by itself, this whole thing is being square rooted. So you have to, being squared. So you have to square root the whole thing. You don't add 3. The 3 is inside, not outside. So you go from outside in, okay? So I square root both sides like that. And I have to do the square root of 36. Now, a lot of you guys can already tell what is the square root of 36, right? Some of you know that already because it's a perfect square. But if you don't, okay, you break it down. 36 is 6 times 6, which is each 6 is 2 times 3, right? I take all of those because they're done. Then you have 2 times 2 times 3 times 3. And you have 2 pairs. You take them out. So, oh, by the way, this side you square rooted, you have the thing inside left, which is x minus 3. Not just x like before, but now it's x minus 3 because x minus 3 is the whole thing getting squared. So I have 2 times 3. So x minus 3 is equal to positive and negative 6. And I have to add 3 to both sides. Well, this is a little bit tricky right here. If you want to add 3 to both sides, you're basically adding 3 to the positive 6 and to a negative 6. So it looks like this, right? So I'm going to split this up. X minus 3 is equal to 6 and x minus 3 is equal to negative 6. I split this into 2 equations so I can solve for it. Now I add 3 to both sides, right? So x is equal to 6 plus 3, or x is equal to negative 6 plus 3. So x is equal to 9 and x is equal to negative 3. Last example. Here's a bunch of numbers, but it's all the same. I gotta get rid of the things outside, right? So I add 3 to both sides, I get 18. I divide both sides, I get 9. And then I do the square root of both sides. Okay? And then square root of 9, we already saw that it's 3 and negative 3. So now I have x minus 5 is equal to positive and negative 3. And again, I have to split this into 2 equations so I can add the 5 to them. So x minus 5 is equal to 3. X minus 5 is equal to negative 3. Like when I add 5, well, I get x is equal to 8, and x is equal to 2. And those are my answers.